All right, MCT4C day 26, first day of chapter 4, which is a unit on exponential functions and exponential equations. And we're starting today with some review of exponent laws, and you're asked to match up the exponent laws. So this one, a to the n times a to the m, well, product of two powers of the same base, you add the exponents. Those are a match there. And so on. One that I want to mention because we're going to be using that today, and it's brand new last year. The other ones were probably grade 10 for most people, but that one right there is a new a to the exponent m over n. Well, fractional exponents like this mean roots, and so it's a radical like this. Roots, radicals, that's what that means. The bottom number is the root, and the top number is the exponent. And we'll see how that works when we get into some exponent law review. So hopefully you got those all matched up. Hopefully these exponent laws are in the back of your brain somewhere and ready for recall. All right, exponent law review. Simplify when necessary, evaluate when possible without your calculator if possible. Be exact. End bracket. 5 to the exponent 3, this is way back when, and what 5 to the exponent 3 means is I'm going to go the base exponent number of times multiplied. Exponents are just a short form for a long list of multiply, and that's 125. Hopefully you can do some of this in your head, but a calculator is okay too. Probably this button on most calculators, that x to the exponent y is the right button. Next one, negative 2 to the exponent 4. If I were to cover up, the minus, then it's just 2 to the exponent 4. 2 to the exponent 4 is 16, so it's minus 16, right? The negative of whatever 2 to the exponent 4 is. Plus 1. 8 to the anything to the exponent 0 is 1, and then I'm adding whatever negative 2 to the exponent 4 is. Well, negative 2 times negative 2 times negative 2 times negative 2 is positive 16. There we go, and that answers 1. And that's pretty weird. Negative 16 and positive 16. This is a place where students mess up. They think that this is the same thing, mostly because they use their calculator and forget to put brackets in. In this one, it's the negative of whatever 2 to the exponent 4 is. Well, the base here is 2. So it's 2 times 2 times 2. That's 16. So it's the negative of 16. In this one, the base is negative 2. The negative is in with the multiplies. Negative 2 times negative is 16, just like I said. That's the difference, right? This is the negative of 2 times 2 times 2. And if you do this in your head, you're not going to mess it up. If you try and put this into your calculator, you got to be very careful where you put your brackets. This one, simple exponent law, dividing exponents. Or dividing powers with the same base, g. I subtract the exponents. I wouldn't expect you to show that step. You can go straight to the answer. All right, onwards. Negative exponents mean, hopefully you remember this, mean 1 over. And we're doing this in our head. We don't want to do these questions with a calculator because we'll get a decimal answer. There will be times when we reach for our calculator, but not right now. Maybe to do 4 to the exponent 3, but 4 to the exponent 3 is 64. It's not that bad. And that's the answer. And notice we are showing our steps moving down the page. This is demonstrating that we understand what the exponent rules are. Negative exponents, again, mean flip, mean invert. So in this case, when it's a fraction, I invert the fraction. Negative exponent means flip. That takes care of that negative exponent. And now I've got 5 over negative 2 squared. So I could think of it as fractions, 5 over negative 2 times 5 over negative 2. Or I could think of this exponent acting on everything in the brackets like this. Again, some of these steps you might skip. Probably I'd be okay if you went straight from there to there. here's one of these fractional exponents. Fractional exponents mean for us to do roots, and the bottom number is the root and the top number is the exponent, 1 in this case. What's the cube root of 8? And if we can do this without a calculator, it's something easy. Something times itself to give 3 times to give us 8. Well, it's 2. Here, I got a fractional exponent again, but I write it as a root first. The bottom number is the root, the top number is the exponent. And when it's the square root, we usually leave that out, but this isn't wrong to write it in, just so we know how to write it as a radical. And now to evaluate this, don't reach for your calculator. Do this in your head. What's the square root of 36? 6. 6 cubed. Maybe you can't do that in your calculator, but I think it's 216. Done. Exact. No calculators. Again, a negative number here, but I'm going to set up the root is the number on the bottom, and the number on the top is the exponent on the outside. Cube root of 125 is -5. And these are kind of things you just got to practice. It's going to be something easy, right? This one, again, it's kind of like that one. I got a negative exponent. Let's deal with the negative exponent first by flipping the base, right? We're a negative exponent, we're inverting the base. We're not inverting the exponent, we're inverting the base. And now this exponent applies on the whole thing. We could do the square root of this whole thing cubed, but it also applies on both of these, the top and bottom. So I could think of it like this. I think this is the easiest way to think of it. The square root of 49 cubed over the square root of 25 cubed, and that is 7 cubed, which maybe again you're reaching for your calculator, and that's okay at that point because I'm still showing all my steps to demonstrate my understanding of exponent laws. And we're good leaving it like that. We're not going to change that into a decimal. The textbook's not very good on the review for this exponent laws, and so that's why there's a handout. Don't write on that homework handout. Do all the work real quick. I think it's going to be a fast, easy homework tonight, and then you can do your FAQ. All right, signing off for now.